Welcome to our notes on inverse functions. Students will be able to find inverse functions algebraically, numerically, graphically, and analytically. Students will be able to verbally explain how to find inverses of functions and verbally describe their properties. So let's take a look at inverse operations. I have a table here of operation and its reverse operation. So if I have addition, the reverse operation is subtraction and vice versa. Multiplication, division. If I'm raising something to the nth power, then I could take the nth root, or I can raise that thing to 1 over n, right? These are equivalent, so whichever one you like the most, you can go with. Okay? And like I said, it's interchangeable here. So there are others, but we will just work with these for now. What I wanted to remind you of is the order of operations, right? Parentheses or grouping symbols first, exponent second, multiplication and division from left to right, whichever one comes first, addition and subtraction from left to right, whichever one comes first. All right, now we have this inverse operations. So it's the reverse operation in reverse order of operations. That's a lot. I'm going to show you an example of what that looks like in example 1a. Example 1a, given f of x, find f inverse of x. Okay, this is not read as f to the negative 1 of x. Please don't say that. It is f inverse of x. So here's f of x. The first thing I'm going to do is replace f of x with y. Okay, so that I see the equation in terms of x and y. It just makes our work a little bit easier. So I'll show you that. Okay, now I'm going to create this table. Okay, my order of operations are here and my inverse operations are on this side. All right, it's going to help me figure out what I need to do first, second, third, etc. In order to get my inverse. So the first thing we have to do is build this equation. We're going to build this equation starting with x. Okay, so I'm going to say start with x. The first thing that happens to x is we add 1. So I'm going to put that there. Okay, now I have x plus 1. What happens to x plus 1? I take the cubed root of that. So that's the next operation. Once I have this right here, I multiply by 2. Okay, and lastly, I subtract 4. Okay, and then I'm going to end with y. This end with y is saying equals y. Okay, so if I'm showing you in order how this works, we start with x, add 1, take the cube root of that, multiply by 2, subtract 4, end with y, right? Notice how what I just have in this laser is the exact same equation up here. Okay, that is what this part is saying. All right, so now let's look at the inverse. Okay, in order to do inverse operations, you must do the reverse operation in reverse order. So I'm going to undo the last step first, right? I'm going to start with y. Okay, then I'm going to undo this one by adding 4. Then I'm going to undo this one by dividing by 2. I'm going to undo this one by cubing. And I'm going to undo this one by subtracting 1. And I'm going to undo this to start with x with end with x. So let me show you how that works. All right, so I'm going to show you a shortcut method, and then I'll show you the long way that you're probably more used to, and you can decide how you want to do this. The shortcut method is me following these instructions here to write my inverse. Okay, so I'm going to start with y. That means write it. Okay, and then I'm going to add 4 to that. Then I'm going to divide all of that by 2. And then I'm going to cube all of that. And then I'm going to subtract 1. And I'm going to end with x. Okay, so I just followed the steps here to write my inverse. Now, with inverses, you have to switch x and y, okay? You have to switch this x and this y. All right, now, once you do that, you should have this. And this y is actually our inverse of f. And that is the final answer. I will say a few things. If you don't like switching x and y at the end, you can always switch it here, okay? So once you write it like this, you can then write x equals 2 cubed root of y plus 1 minus 4. And the only difference is that instead of saying start with x, you will say start with y, end with x. And you will start with x, end with y, and then you will get to this instead, okay? So you can switch first or you can switch last. It's up to you. Just do one or the other. All right, so let me explain a little bit more why that shortcut earlier works. This is the longer way of doing things, and if you prefer doing it this way, that's totally fine. Everything that is on this side is telling you what you need to do to both sides in order to get x by itself, right? So first we built this equation from x. Now I have to unbuild it so I get x by itself. Okay, so I'm going to rewrite this on this side so I can show my work vertically. I want to get x by itself. That's the goal. So the first thing I have to do is add 4 to both sides. Notice that that was my first step, right? Besides starting with y, which is already on your paper, right? The first thing I do is add 4 to both sides. And this is what I'm left with, okay? The next thing, I have to get rid of that 2. So I'm going to divide both sides by 2. All right, so that's what that looks like. And then I'm going to cube it, cube both sides so I can get rid of that cubed root, okay? And that's what I'm left with. And then I'm going to subtract 1 from both sides to get x by itself. And notice that this was the same equation that we had when we did the shortcut, except I put the equals x over here. I put that like that, but that's fine. And then, you carry on, you switch the x and y, and then you change that new y to f inverse, and you got the same thing. So this is why the shortcut works, because the shortcut is only focusing on the left-hand side here, okay? Oops. It's only focusing on the left-hand side. So go back and check out the shortcut method. If you like the shortcut method, write that down for your algebraic. If you like the long way of doing it, that's fine too. Write this down. Example 1b. Let's look at the inverse numerically using a table. So here we have the original function f of x, and the inverse of f is what we found previously in example 1a. So if I were you, I would pause the video, and without a calculator, I would evaluate this function at these x values. Also without a calculator, evaluate this inverse function at these values. Okay, so pause the video, try that on your own first. All right, so example 1c says graph it. I decided to graph it on a separate sheet of paper because the graph that I originally had on my PDF does not have appropriate scales. Like the x-axis and the y-axis are not in the appropriate space. So I went ahead and just drew my own graph on a separate sheet of paper, and I plotted f of x in the bright orange color, and I plotted the inverse of f of x in the green color. So now what can you say about these graphs? As you can see, if you happen to have this graph on your paper, then that's why I decided to graph it on a separate sheet, so I can graph my table of values and connect with a continuous curve. So this wasn't the best graph for it because I see more positives. I see like the first quadrant very well, but I don't see like my second, third, and fourth quadrants very well. So I just did it on a separate sheet of paper. Now let's focus on example 1D, analytical. It says find the domain and range of f of x and the inverse function using the graph. What do you notice about the table below? Okay, so analytical. I happen to put the domain and range of f of x in the inverse function here. It's kind of hard to see what you notice about the tables because the domain and the range for both f of x and f inverse of x are all real numbers. So you can't really see what happened there. But maybe you might be able to pick this up for the x-intercept and the y-intercept of each function. So the x-intercept of f of x was 7, 0, and the y-intercept was 0, negative 2. The x-intercept for f inverse is negative 2, 0, and the y-intercept for f inverse of x is 0, 7. What do you think happened? And here's a hint as far as the x-intercept and the y-intercept, the domain and range, and even what happened in this table, they are all related. All right, so whatever you came up with the relationship for the two tables should be similar to what you think about the domain and range and the x-intercept and y-intercept. All right, so we have a bunch of inverse facts. We're going to be writing a couple of definitions here. So a function, we should all know, is a relation where every input has only one output. The vertical line test is a visual test to determine if a graphed relation is a function. Okay, so first we graph the relation and then we use the vertical line test to determine if it is a function. What is a one-to-one function? A one-to-one function is a function where every output has only one input. And the horizontal line test is a visual test to determine if a function is one-to-one. I wonder what happened between those definitions, right? Are you seeing like a recurring theme here? I hope so. All right, let's look on the next one. When will a function have an inverse function? A function will have an inverse function only if that function is one-to-one. All right, so you need that one-to-one condition in order to find its inverse. All right, so if a function is not one-to-one, think a quadratic, then you must restrict the domain so that it is one-to-one. Right? And on that restriction, you can find an inverse, okay? But only on that restriction, not for the whole thing. Okay. Composition of functions. If you have f of x and g of x, and they are inverses of each other, then f composed of g of x will equal x, and g of f of x will equal x. That was a lot. So f composed of g of x is x, and g composed of f of x is x. Okay, so you should have this when you perform that composition. If you do, then you can conclude that f of x and g of x are inverses. All right, so now a little bit of practice for yourself. I want you to do this without a calculator. Check your work with the calculator after you've tried it, okay? So here's the algebraic. F of x equals 3 times the square root of 2x minus 1 plus 5. I want you to graph it down here, and I think this is an appropriate scale for that. And then do the analytical, right? Find the domain and range of f of x and the x-intercept and the y-intercept of f of x, as well as its inverse.